All right, so starting the new indicator, this is 9.1. 9.1 is interpreting graphs. So the nice thing about 9.1 is that it is not much actual math. It is more thinking, critically thinking, reasoning what the graph means and what the different axes mean and what the rise and fall and all of that of the graph, what it means, and then you'll answer questions regarding the graph. A couple of things to note. The title of the graph is very important. It gives you information that will help you answer the questions. Also, the names of your axes. So the x-axis is always the one that runs left to right. That's your bottom axis. In this instance, the x-axis is time in hours, and you always want to watch time because it could also be in minutes, but in this case, it's in hours. And then your y-axis, or your up and down axis, in this case, is distance from the dock in miles. And so the title of the graph, along with the names of the two axes, will help you interpret and answer questions about the graph. Okay, so let's kind of jump in to this first question here. And it says, what is happening in section AB? And then it says, include the minutes. Well, what this is asking is, when it says what is happening or explain the segment or anything like that, what it means is what is happening on both graphs in that section, not both graphs, on both axes. So anytime you explain what is happening, you want to, in your explanation, you want to have what's happening on the x-axis and what's happening on the y-axis, okay? So in this instance, right, let's look at this. What is happening in section AB? Well, first let's look at the x-axis between A and B. So between A and B is between here and here on the x-axis, right? That's section AB. Well, between section AB, how much time is passing? 1 hour. Good. Now let's look at the y-axis. So for the y-axis from section AB, that is from here to here, right? That's section AB. What's happening in section AB along the y-axis? It's increasing by 40, but it's what? 40 what? Miles. So if from A to B, you go 40 miles, right? So there's a couple things you're going to want to write here. You go 40 miles in 1 hour. How's another way to write that? 40 miles per hour. That works as well. And the reason that works is because you're saying 40 miles, so that takes care of the y-axis. In 1 hour, that takes care of describing the x-axis. It's very important that you describe what's happening in both in every description, okay? So 40 miles per hour is what is happening in section AB, right? And what is it that's happening in that time? Well, it's the boat traveling, right? The boat is traveling 40 miles per hour. All right, so it says, what is happening in section BC? Well, first of all, let's look at section BC, okay? And section BC is between here and here. So how much time is elapsing just in section BC? 1 hour again. And the knee-jerk reaction, or the thinking like too quick kind of thing, is people look at that and say, well, that's 2 hours. Section BC is not 2 hours. From A to C is 2 hours. But from B to C is just that 1 hour, okay? And then let's look at our distance. From B to C, how much distance is covered in that hour? So what is happening if there's no distance covered for that hour? What is the boat doing? Yeah, it's staying still. It stopped. So your answer to number 2 would be that the boat is stopped. Now, stopped is the distance. What else do we need? Yeah, stopped is the distance. For 1 hour takes care of describing the time. So for every description, you're going to have a description of the one axis and a description of the second axis. If you just say the boat is stopped, that's only half right, okay? All right, so now it says what is happening in section CD. Okay, so I'm going to go back up to the graph here, and we're going to look at just section CD. So along CD, we've got from here to here. So how much time elapsed? Just 1 hour, right? From C to D is just 1 hour. And then from C to D, how much distance is covered? 30. And it's the knee-jerk reaction is to say 70, right? Because if you look at the D point, it's up there at 70. And from the very beginning of your trip to D, it is 70 miles. But just from C to D, right? You just want to go from C to D, and that space right there is from 40 to 70. So that's a 30-mile distance there. And so because it's in 1 hour, can we write it like this? 30 miles per hour, right? That's what's happening is the boat is traveling 30 miles per hour from C to D. Okay, everybody got what I got there? All right, so now let's look at section DE. So it's the same thing, right? We're going to just section out DE. So DE along the bottom is from here to here, so that's 1 hour. And then from D to E, right, that's from 70 to 80. So how far did we travel just in that DE spot? 10 miles what? Per hour. Now, something that I want you to be mindful of, and we're going to add it up here. We're just going to add a little asterisk here because in all of these questions, everything was in these nice little 1 hour chunks, right? But what if I ask you, what is the average speed from C to E? Oh, not D. I said E and I still wrote D. So I want to know the average speed, or miles per hour, right, from C to E. Well, let's just break that down a little bit. So we just want from C to E. So first of all, we're going to go from C to E. So how many hours is that? 2 hours, right? And then from C to E is, from C to E is how many miles? 40. But I want it in miles per hour. So if you go 40 miles in 2 hours, how many miles do you go in 1 hour? Yes, 20 miles an hour is the average speed. Because speed is always in miles per hour. So you wouldn't leave it 2 hours at 40 miles because that's not the average speed. Okay, speed is always, if you think about it, your speed along the interstate, it's 65 what? Miles per hour, 35 miles per hour. They don't ever say you can go 120 miles in 2 hours on a road sign, right? Everything is always based on miles per hour. So you always want to write your answer if you're talking about speed. And when it says include units, that means miles per hour. If you're ever talking about speed, you always want to reduce it down to miles per 1 hour. So if you go for 2 hours, you have to divide it in half. If you were to go, what if I said they went 90 miles in 3 hours? What would their average mile per hour be? 90 miles in 3 hours? 30. Yeah, 30 miles per hour. So you always want to divide it down to where it's miles per 1 hour. Okay? All right. Now it says, this is where just thinking about what the graph means comes into play here. Because now the next question there, number 5, says, where is the boat at point A? Where's the boat at point A? Yeah, this is where it's important to know what your title of your graph is and what your axes are. Because here is point A, right here. And point A is at this 0, 0 mark. And so where is the dock at, where is the boat at 0, 0? Well, since it's distance from the dock, your original point is the dock. So your answer to where is the boat at point A, the answer is at the dock. Okay. Then it says, where is your boat at point C? Here's point C right here. So where would we say our boat is at point C? How could we reference it to the graph? Yeah, 40 miles from the dock, because at point C right here, right, they're 40 miles. 40 miles from what? Well, you have to always reference the graph. So they are 40 miles from the dock. Okay? All right, so where's the boat at point E? What do you guys think? Yeah. And again, this is where the title of your graph comes in. Because if you look at the X and the Y axis, there's nothing about an island, right? So if you don't read the title of your graph, which is a boat traveling from the dock to the island, you wouldn't know that that end point is the island. So in this instance, point E is at the island. Now I want to ask you this. What if the title of the graph had just been boat traveling from the dock? And your question was, where is the boat at point E? What would you put? Do what?
80 miles.
No, 80 miles from the dock. So if the title of the graph had just been boat traveling from the dock, and you don't know where the end point is, the only point of reference you have is the dock, right? So that means all of your distances are from the dock, from the dock, from the dock. But since the title of the graph says from the dock to the island, that's a hint or a clue that your end point is the island. So if you had answered this one, and your answer for number 7, if you had put 80 miles from the dock, you would have gotten half credit. Because technically it's right. It is 80 miles from the dock. And even though it's a right answer, it's not the best answer because you have more information than that. So use whatever information you have to answer your questions as descriptive as possible. And if you know the endpoint, then your endpoint is going to be named. If you don't know your endpoint, then it's just going to be so many distance from your beginning point. But always reference what you have, okay? All right, and then it says, which segment shows the boat's fastest rate and explain. For this, I don't want you to use the miles per hour that we figured, okay? We're just going to look at the graph. And looking at the graph without doing any math, without figuring out any miles per hour, can we just look at this and see which segment was the fastest? Well, this takes us back to when we learned about linear equations and we learned about slope, right? And so if something has a steeper slope, it has a higher rate of change or a higher speed of change. So if you have, say for instance, this flat spot right here, what do we know about the slope of a horizontal line? Does anybody remember what the slope is? Here's a clue. Yeah, it's 0. So the slope of that B to C is 0. It's a flat line. There is no rate of change. But if you look at the slope of AB versus CD versus DE, which one has a steeper slope? Yeah, AB is definitely the line that gets up there the quickest, right? It definitely is the steepest. You think of a hill, right? This one has kind of a medium incline. This one has a little bit less of an incline. This one is completely flat. There is no incline. So the segment where there's the fastest increase or the fastest rate of change is there between AB because it is the steepest slope. So for your answer for number 8, which segment shows the boat's fastest rate? The answer is AB, and the reason or the explain is because it has the steepest slope. And that's the reason that you know that segment has the fastest rate. And does that play out with what we saw about our miles per hour? We have a 40 mile an hour spot. We have a stopped, we have a 30 mile an hour and a 10 mile an hour, and that AB is the 40 mile an hour segment. So that does play out that not only visibly can we see that that's the fastest segment, but it also plays out in the math of it when we actually figure the miles per hour. Okay? Any question on that? It's all a matter of looking at the title of your graph, looking at your two axes, what they're named, and then breaking down what each segment is telling you. All right, any questions on this? All right, for the second one, we've got Christy and Jacob are going on a walk. Excuse me. And Christy, her line is labeled with her name, and Jacob's is with his, so you got to kind of keep track of whose line is who. And then the bottom is time in hours, and the side, the y-axis, is distance from the school. So that's a hint about where they're starting. Okay, so the first question there, before we do any math whatsoever, it wants to know which walker is faster. What do you guys think? Why Jacob? Yeah, because his line is steeper. So what walker is faster? It's Jacob. And it's because he has the steepest slope. Okay, that's why he's fastest. So before we do any math, we can tell that he is the fastest walker. Okay? All right, now it wants us to calculate how fast is Christy walking. And again, right, our answer is going to be miles per hour. So let's take a 1 hour block. So let's look from this hour to this hour. Let's look and see what Christy does. How far does she travel in that 1 hour? Okay, I've got one saying 1 mile. What do you guys think? 1 mile? Anybody think 2 miles? Good. That's a common mistake, because what the tendency is to just go up here to this 1 and boom, right? There's Christy. And that's at 2 miles. And so that's the mistake. But where does Christy start? She already started a mile away from the school. So in her 1 hour, right, she didn't start down at 0. She started a mile from the school. And after 1 hour, she is now 2 miles from the school. So in that 1 hour, she only went 1 mile. So she would be 1 mile per hour. Now let's look at Jacob. And again, right, we're going to look at that 1 hour mark for Jacob. And here's the 1 hour mark. And if we follow that up to Jacob, that's here. Did Jacob start at ground 0 at the school? Okay, so his would be a true reading, right? So from 0 up to, what's that? 1.5. So in 1 hour, he went 1.5 miles. So you could write that as 1.5 miles per hour. And if you didn't have a really good, right through a good cross point to see the 1 hour mark, you could also, like let's take Jacob for example, we could also go out to this 3 mile an hour mark and come up here. And if we do that, oh, that's not what I wanted to do. Sorry, I meant 2 hour mark. I mean, we can do 3 hours, but it works out better if we do 2. You could also come out to this 2 hour mark and see that he went 3 miles. And if he went 3 miles in 2 hours, that equals 1.5 miles per hour. So you can see that you still get the 1.5, okay? Same with Christy. If you took Christy's starting point, which was here, up, right, she went 2 miles, right? She went from the 1 mile mark to the 3 mile mark. So she went 2 miles in 1 hour, or in 2 hours, which equals 1 mile per hour. So if you don't have a real good intersection at the 1 hour mark, you can go out to the 2 hour mark if you have a better intersection. You just have to make sure and divide it, because if you go 3 miles in 2 hours, that's only 1.5 miles per 1 hour, because you always want to do your miles per hour based on 1 mile. Okay, so we've got their miles per hour. And does their miles per hour jive with what we got as far as who was faster? Right? We predicted that Jacob would be faster based on his slope. And it does play out math-wise. Christy's going 1 mile an hour. Jacob's going 1.5 miles per hour. So yes, he is going faster. On the homework, I had somebody predict that one person was going faster than the other, but then they got both of their miles per hour as 3 miles per hour. That should be a big red flag that you tallied one of their speeds wrong. Because if you got both of them are at 3 miles an hour, but one of them has a steeper slope, they can't be going the same speed. So just watch that, okay? All right. At what time and at what distance from school will Christy and Jacob meet? What do you guys think? Yeah, it's where their lines cross. So right here is the intersection of where their two lines meet or where their two paths meet. And so for time, right, and this is where you got to be really descriptive, right? The time would be what? 2 hours from what? When they had lunch, when they went to bed, when they tied their shoes. 2 hours from what? Yeah, their start. This is where being descriptive, right? I'm saying the hours and I'm saying the distance. So 2 hours from their starting point. And then it says, at what distance from the school? So what's the other half of our answer? 3 miles what? From the school. So you always want to put the distance and the time in all your answers. Okay. All right. So it says, why do the two walkers have different y-intercepts? What do you think? Emma Kate, what do you think? Why do they have different y-intercepts? They have what? Well, they walk at a different rate, but think about the y-intercept, what it means, right? This is our y-axis right here. And what is our y-axis talking about? The distance from the school, right? So if Jacob's y-intercept is right here and Christy's y-intercept is right here, what does it mean? Did they both start at the school? Okay, who started at the school? No. Jocelyn, what do you think? Who started at the school? Yeah, Jacob was at 0. So he's 0 distance from the school. So that means his start point is the school. Braden, where did Christy start? Right. So what do their y-intercepts mean? It means what? Paul, what would you say? We just went over it. Yeah, they didn't start at the same place. Why do the two walkers have different intercepts? Because they started at different places. Okay, so then it says, express each walker's starting point as an ordered pair. So for Christy, Olivia, what do you think Christy's starting point would be as an ordered pair?
0, 1.
Good, 0, 1. And Jordan, what do you think Jacob, trying to say Jacob and Jordan in one sentence is a pain. All right, sorry, Jacob. Jordan, what do you think Jacob's starting point would be? 2 would be the y-intercept, or 2 would be up on the 2 on the y-intercept. Where did he start from? Oh, let's look back at the graph here.
0, 0.
Yeah, there you go, 0, 0. Jacob's starting point is 0, 0. Kind of wrote that wonky, but. All right. So 0, 0 for Jacob's starting point. All right, what does the x value represent of their starting point? What does the x value represent? Just anybody, what do you think? Yeah, their start time. Okay. And what does the y value represent? Yeah, distance from the school in miles. She's killing it, isn't she? Distance from school in miles. Okay, so now it says, how long will it take Christy to walk 7 miles from the school at her current rate? Well, let's go back to our graph here. And our graph is well short of trying to figure out 7 miles, right? If we try to go up to 7 on the distance, we'd be so far off the graph. But what information do we have about Christy's rate? Yes, and how fast is she going?
1 mile per hour.
Okay, so she goes 1 mile per hour. How long will it take her to go 7 miles?
7 hours.
7 hours. Good. That is one long walk. Go Christy, right? So 7 hours is how long it will take her to walk 7 miles. And the reason is because she's going 7 miles per hour. And then it says after 3 hours of walking, where would Christy be? So let's go back to our graph here. And again, it's really important to remember which line is Christy's, right? So we're following Christy's line all the way up here, right? That's Christy's line. And it wants to know at 3 hours, where will she be? From the school. Very good. 4 miles from the school, because we don't know their end point, right? It doesn't tell us their end point. All we have is from the school. So she will be 4 miles from the school. Good. All right. Any questions on that? All right. So for those of you at home, go ahead and open the assignment on Kami and complete it and submit it. And then for tomorrow, there'll be another video just like this with another day 2 worksheet, and that you'll complete through Kami as well. And then for those of you in class, I've got paper copies of all of these. So everybody, of course, if you need me, email me if you have any questions.